class we are going to discuss about two important things. One is about the chemical equation and another is about significant figures. Okay. First let me discuss about the chemical equation. So in chemistry, chemical equation is very important, children. When you go to higher classes, you will learn in detail about the chemical equation. Okay. What is meant by chemical equation? Chemical equation is a symbolic representation of a chemical change. Otherwise, we can say chemical equation is a shorthand notation of a molecule of a given substance by using formula, symbols, etc. Okay. If you take the chemical equation, this chemical equation it consists of two components. Okay. What are they? What are the two components? One is the reactants and another one is the products. Okay. So what is the difference between reactants and products? Reactants means a substance, okay, which takes place in a chemical reaction, that takes part in a chemical reaction is called the reactant, whereas product means the substance, the final substance, okay. We get one final substance, no. So that is nothing but the product which we are getting at the end of the chemical reaction. These are the difference between reactants and the product, okay. Now let me see some examples. What is the reactant? What is the product? That we can see now. So first one, you should know about the chemical equation. It's a very important 2-mark question. Okay. So chemical equation means chemical equation is a symbolic representation of a chemical change by using symbols as well as formula. This is called the chemical equation. Right, children? Good. Now we can see one example, right? 2H2 plus O2. O2 is nothing but oxygen, whereas H2 is hydrogen. Okay. 2H2 plus O2 gives 2H2O. Okay. Here the left hand side you are seeing no H2 plus O2. H2 is nothing but hydrogen, whereas O2 is oxygen. These two are the reactants. Okay. This hydrogen as well as oxygen are reactants. At the same side, right hand side, 2H2O you are getting no. This is the product. Okay, this is the product. So what is the meaning for this? Two molecules of hydrogen combines with one molecule of oxygen to form two molecules of water. Okay, so these two hydrogen and oxygen are reactants. These reactants take part in a chemical reaction, whereas this H2O is nothing but product which is obtained from this chemical reaction. That's the difference between reactants and products. Got it, children? Right. Next example we can see sodium when it combines with chlorine it gives sodium chloride. Sodium chloride is a compound which we use in our day-to-day life, daily life, isn't it? We say it is a common salt or table salt. The chemical name of common salt is nothing but sodium chloride. So sodium when it reacts with chlorine it forms sodium chloride. Okay. So this is the word equation. Now what we have to do? We have to write this word equation by using symbols as well as formula. Okay. So what's the symbol of sodium? Na, isn't it? So Na is nothing but sodium. That is plus chlorine. What's the symbol? Cl2. Okay. So Cl2. Na, that is sodium, plus Cl2 is chlorine. Both react to form two molecules of sodium chloride, and the formula of sodium chloride is NaCl. Got it, children? Right. So next example, copper. Okay, copper when it reacts with the sulfur, both copper and sulfur reacts to form copper sulfide. Okay, so this copper when it reacts with sulfur to form copper sulfide. So what is the formula? What is the symbol of copper? Cu. What is the symbol of sulfur? S. Cu plus S product. Okay, here in this Cu plus X, it is in the left hand side, so it is the reactant, and CuS, that is copper sulfide, it is the final product which we obtained, isn't it? When copper reacts with sulfur, it forms copper sulfide, so this is the product. Understood, children? Right? Here sodium, when it reacts with chlorine to form sodium chloride. Hydrogen, when it reacts with oxygen to form the water. Okay, so these are the reactants, whereas the final product what you are getting, that is called the product. Understood, children? Now you know the difference between the reactants and products, isn't it? Okay, so next one, you have to know about the skeleton equation. What is the skeleton equation? See, the symbols and formula on both sides are added by plus sign. Okay, positive sign, that is plus sign. This is called the skeleton equation. For example, here, if you see the sodium as well as chlorine, here the symbols as well as formula, when it combines with this plus sign. Okay, so both sides are added by the plus sign. This sign. This, now you can say this equation is called the skeleton equation. Okay, so the symbols and formula on both sides are added by plus sign, then it is called skeleton equation. Next, while writing the chemical equation, we have to follow some rules. Okay, what are they? First one is upper arrow. Okay, upper arrow mark is written immediately after the gaseous product. Suppose the chemical equation is obtained, means if that product is when it is in the gaseous form, okay, then what you have to do? You have to write the upper symbol, upper arrow mark like this. Okay, after getting the product, you have to immediately write the upper arrow, right? For example, we can see two molecules of water, that is 2H2O, right? 2H2O on electrolysis. Electrolysis means what? On passing electricity. Okay. So 2H2O on electrolysis gives 2H2 plus O2. Okay. H2 is nothing but gas, isn't it? Okay. This point I will tell you at the last. Okay. While writing the chemical equation for each and every reactant as well as product, we have to mention the states of matter that I will tell you in the third point. Okay, so for what we have to do, we have to write the, if upper arrow we have to put is written immediately after the gaseous product. So water on electrolysis gives hydrogen as well as oxygen. You know very well oxygen is a gas, isn't it? So you have to put the upper arrow like this. This is only applicable for gaseous product, and you have to remember, right children? Good. So next we can move to the second point. Lower arrow is written immediately after the insoluble substance. If it is solid, insoluble substance means if it is solid, which deposits from a solution. Okay, first for gaseous product what we have to do? We have to put the upper arrow, and for lower arrow what we have to put? If the insoluble substance which deposits from a solution, means if the product is insoluble substance, means that is solid substance, means you have to put the arrow mark. Okay, lower arrow we have to put like this. For example, ammonia. This NH3 is nothing but ammonia. Ammonia, when it reacts with the hydrogen chloride, HCl is hydrogen chloride. Ammonia, when it reacts with hydrogen chloride, it forms ammonium chloride. Okay, it is a solid, insoluble substance. So what we have to do? You have to put the arrow, lower arrow like this. Got it, children? NH3, when it reacts with HCl, it forms an insoluble substance, solid substance, NH4Cl. So what you have to do? You have to put the downward arrow, lower arrow like this. Got it? This is the second point. First point, after getting the product, if it is gaseous substance, means we have to put the upper arrow, and product is insoluble substance, solid, means we have to put the lower arrow. That is the second point, right? Next, the third rule is what we have to do? Symbols. Okay, we have to write the symbols. Okay, you know very well the three states of matter matter or solid, liquid as well as gas. If a chemical reaction takes place, means that chemical reaction takes place not only in one state, in all the three states of matter. Okay, solid substance also will come, liquid substance as well as gaseous substance also will come in the chemical equation. So what we have to do, we have to write the reactants as well as product. We have to mention the reactants as well as product. Whether it is a solid, means we have to put inside the bracket small s we have to put. If it is the liquid substance, means small l we have to put. If it is gaseous substance, means we have to put small g. Like that we have to mention the symbols for each and every reactant as well as product. Substance. Okay, substance. What are the substance that we have to include? For example, I will tell you. See, symbols S for solid, L for liquid and G for gas should be written in a chemical equation. For example, we can take C3H8. C3H8 is propane, it is a gas. Okay, so this one, when it reacts with oxygen, O2, it gives 3 molecules of carbon dioxide, CO2 plus water. Okay, this substance we get from this chemical equation. Here you have to mention. Okay, so this C3H8 is nothing but propane gas. So it is a gas. So we have to mention G. Okay, if it is gaseous substance, means you have to mention that specified states of matter, physical state of matter. This is a gaseous substance, so we are putting G. And oxygen is also, it is also a gaseous substance, so we have to put G like that. And CO2 is carbon dioxide, we have to put a G here. And next one, water, we are getting from this gaseous substance, so it's also it is also in the gaseous form, so we have to put G like that. Okay, like that we have to mention. For this we can see ammonia. Ammonia is nothing but a gas, so we have to put G like that inside the bracket in small letters. Okay. And hydrogen chloride is also a gaseous substance, so we are putting G. And ammonium chloride is an insoluble solid substance, so we have to put S here. Okay. If it is L, means you have to put. If it is liquid substance, means we have to put L. For example, you can take 2H2 is nothing but a liquid substance, water, isn't it? So we have to put L here. And hydrogen H2 is a gas, that's what we are putting G. And oxygen is a gas, we are putting G like that. Understood, children? These 3 rules you have to remember. Next one, if your substance is dissolved in water, means we have to mention AQ. AQ means aqueous solution. What is the meaning for aqueous solution? Aqueous solution means a substance dissolved in water. Okay, if a substance dissolved in water, means we have to mention AQ inside the bracket here like that. In this manner we have to mention. This is the 4th point. Understood, children? First point, what you have to do? If you have to put the upper arrow after if the product is a gaseous substance, immediately you have to put the upper arrow. If the product is an insoluble solid substance, means you have to put the lower arrow immediately. And third one, you have to mention the physical states of matter, whether it is a solid or liquid or gas. If it is an aqueous solution, that is a substance dissolved in water, you have to mention AQ inside the bracket. These 4 points you have to remember while writing the chemical equation. Understood? So one more we can see. See here, CH4. CH4 is nothing but methane gas. Okay, CH4 is nothing but methane gas. So it is a gas. Plus O2. O2 is, you know very well, it is an oxygen. Oxygen is also a gas. So we have to put the physical state here. Next is CO2. CO2 is a carbon dioxide. It's a gas, isn't it? So we have to put G here. And finally water, which we are getting from gaseous substance. So G we have to mention. Here, this equation, what it resembles actually, that is 1 molecule of methane. CH4 is nothing but a methane. Methane is a gas. Okay. So 1 molecule of methane, when it reacts with the 2 molecules of oxygen, gives carbon dioxide. 1 molecule of carbon dioxide plus 2 molecules of water. Okay. One more thing we can say in the same manner. 1 mole of methane when it reacts with 2 moles of oxygen gives 1 mole of carbon dioxide plus 2 moles of water. Okay, so in this manner also we can say. So what do you understand from this? We can understand that from this equation we can understand that 1 volume of methane when it reacts with the 2 volume of oxygen gives 1 volume of carbon dioxide plus 2 volumes of water. Okay, in this manner we have to write the chemical equation, right children? And also while writing the chemical equation, we have to balance the chemical equation because you might have learned about the Lavoisier's law of conservation of mass. According to law of conservation of mass, the total masses of the product are always equal to the total masses of the reactants. So we should balance the chemical equation. Okay, we should balance the chemical equation. This balancing chemical equations and all you will learn in your higher classes. That is in 8th standard. You will learn about how to balance the chemical equation. But balancing chemical equation is necessary. It is very important as per law of conservation of mass. Right, children? Yes. You are clear about the chemical equation? Good. We can write many chemical equations. We can do the exercise in our classroom. Okay. The remaining many chemical equations we can do it in the classwork. Now we can move to the significant figures. What is meant by significant figures? It is mainly used to mention the accuracy as well as precision. Okay. It is very important and also it is a fundamental thing. What is a significant figure? Significant figure is the digits of a number that are meaningful in terms of accuracy and precision. Okay, in terms of accuracy as well as precision, right? Good. So, while writing the significant figures, we have to follow some rules. Okay, based on that rule only we have to mention the significant figures. What are the fundamental rules? Let me see now. The first rule is all non-zero digits are significant. Okay, see, all non-zero digits are significant. I'll tell you some example. If you take this digit, that is 42.3, here any zero digits are there? No. Here no zero digits, isn't it? What's the first point? First rule is all non-zero digits. Okay, these three are non-zero digits. So all non-zero digits are significant. How many significant figures are here? 1, 2, 3. So 3 significant figures are in 42.3. Okay, you have to learn this rule. Based on this rule only, you can write the significant figures. All non-zero digits are significant. Here there is no zero. So all the digits you have to count the digits and you have to mention. This is the 3 significant figures is the answer for the first one, right? Next, second you can move. 243.4. Here also there is no zero digit, isn't it? So this is one figure. 1, 2, 3, 4. So how many significant figures are here? 4 significant figures are in 243.4, right? Next, come to the third one. 24.123. Here any zeros are there? No zeros. So how many significant figures are there? 5. How? 1, 2, 3, 4, 5. No need to mind about the decimal point now, right? So this is the first rule. Understood, children? Right. Next we can move to the second rule. 0 becomes significant figure if it appears between two non-zero digits. Okay, what is the second rule? 0 becomes significant figure if it appears between two non-zero digits. If you look at this example 5.03, okay, here you can say significant figures are 3. 1, 2, 3. Why we are taking this 0 zero as significant figure. In the first, what I told, all non-zero digits are significant. But here, this zero we are taking it as a significant figure. Why? That is based on the rule. What is the rule? Zero becomes significant figure if it appears between two non-zero digits. So this is a non-zero digit. This is a non-zero digit. 5 and 3 are non-zero digit, isn't it? But this zero appears between these two non-zero digits. So as per the second rule, we have to calculate this second zero also. So 1, 2, 3. How many significant figures are in 5.03? 3 significant figures. Right, children? Good. Next, we can move to this. 5.604. Okay, 5.604. Here also, this zero, it appears between 6 and 4 digits, isn't it? So we have to count the zero also. So 1, 2, 3, 4. How many significant figures are there? 4 significant figures. Understood, children? Right. Shall we move to the third rule? Good. Leading zeros or zeros placed to the left of the number are never significant. You have to remember this one. Zero placed to the left of the number. Left of the number are never significant. For example, if you take 0.543, in this here, 3 significant figures are there. What are they? 5, 4, 3. That is 1, 2, 3. These 3 are the significant figure. This 0 we cannot take it as a significant figure. Why? What happens? As per the rule, see, zeros placed to the left of the number. This is the number. The 0 is placed actually left to this number. So we cannot take the 0 as significant figures. We have to count these 3 values only. So that's what we are getting the answer 3. Understood, children? Next one. 0.045. Here, what as per the rule? 0 is placed to the left of the number. So this here for 4, 5 is given. This 0 is placed left to this 4 and 5. So we have to take 4 and 5 only answer. That's what the significant figure of 0.045 is 2 only. That is 4 and 5. These 2 digits only. That's what we have to take 2. Understood, children? Right. And the last one, trailing zeros placed to the right of the number are significant. Okay. Trailing zeros placed to the right of the number. This point you have to remember. Trailing zeros placed to the right of the number are significant. For example, see 433.0. Okay, so trailing zeros placed to the right of the number are significant. So this 433.0, this 0 is placed right to this number. So this one is a significant figure only. So how many significant figures are there in 433.0? 1, 2, 3, 4. We have to count the 0 also because as per rule it is in the right side of the number, right? So 4 significant figures. Next one, 3.4000. Okay, so these zeros are placed to the right side of the number, isn't it? So we have to count now 1, 2, 3, 4, 5. So how many significant figures are here? 5 significant figures. And the last one, see 0.20. Okay, this 0 is in the left hand side. So right hand side you have to count 1, 2. So how many significant figures? 2 significant figures. So while writing the significant figures, you have to remember the rules. You have to learn the rules. Without knowing the rules, you cannot write the significant figures. Right, children? First learn the rule, and based on that you will be getting some decimal numbers and so based on that you have to count the figures and you have to write. In this manner only we can write. It's purely based on the accuracy as well as precision. Scientific notation as well as many more exercises based on the significant figures we can discuss in the classroom, children. Okay. So what are the 2 things we discussed today? One is about the chemical equation and another one is about the significant figures. Both are very important. You will get many questions, mainly need-based questions you will be getting from these two. Okay, chemical equation you will be getting theory-based, and significant figures mostly you can expect this from need-based question. Okay, it examine the accuracy as well as precision of that measurement, right children? So go through everything and work out all the what are the examples we have given here, not only significant figures, even in the chemical equation also, everything you work it out. Okay, you go through everything, and the remaining things we will see in the classroom. That's all children. Go through all the things, especially you have to learn the what is meant by chemical equation, define chemical equation, and what is the purpose of writing the significant figures. These two things especially you should know about it, and also rules are very important. Rules not only for significant figures, even for chemical equation also I have told some rules. Based on that only we have to write the